All right, here are some of the answers for the homework from Monday. I would suggest you pause it. I'm going to move through, and you can check your answers and then bring it in on Wednesday. Okay, here's 25 through 39, pause. And then 41A, B, 43, all the way through 47. Give those ones a look. Remember, you're working towards your test on February 5th. And just as a reminder, I'm probably going to break this up into 2 separate videos. I'll just go through exponential growth right now, and then in the next video I'll do the interest, compound interest, and exponential decay, since about 30 seconds has been taken up by homework. Okay. Growth and decay. Growth is about, obviously, growth. Okay. Decay is about something wasting away. You're going to see this. It looks familiar. This is the definition of an exponential growth, but it also is an exponential function. Except here we know that A has to be bigger than 0 and B has to be bigger than 1. Okay, remember the other one, B didn't have to be bigger than 1. It just had to be positive. The base B is the growth factor. This value B is going to be how quickly things are growing, which equals 1 plus the percent rate of change. Okay, so we'll see that as we go. So A is the initial amount. It's how much we start with. B is the growth rate, which is greater than 1, so it's 1 plus some other percentage, and then the x is an exponent. This is what they're going to look like. Okay, where O comma A is going to be the value of the A that we see there. Okay. Since 2005, the amount of money spent at restaurants in the United States has increased by 7%. So this right here is the growth per year. And in 2005, this is the starting. Okay. So A represents the value we start with, so $360 or 360 billion. And then this B, 7%, is 1 plus 0.07. It's growth, so it's going to be higher than 1% or 100%. So B is now 1.07 to the power of x. Okay. A is the starting point, in this case 360 billion spent in 2005, and this is the growth rate taken to a power of x. The question asks, how much will there be spent at restaurants in 2015? So that's 10 years beyond what we already know. So 1.07 to the power of 10 times 360 gives us an answer of $708 billion being spent at restaurants. Okay, so look over that one if you need to, pause it, whatever. I'm going to move on. Okay, continuing. This one asks, what does it look like as a monthly number? Okay, that right there was yearly. So we're asking, how much does it change every month? This one's not that difficult. We have our yearly increase, 1.07 to the power of x. This is 1 times x. We need to know it monthly, so we do 12 over 12, because there are 12 months in a year. We pull out 1.07 to the power of 1 over 12 to the 12x. That's the same thing. Okay, 1/12 times 12x is 12x over 12. That becomes 1.0057 to the 12x. And then we just simply replace this with the letter m for 1 month. So that is the expression that we would use to represent the monthly increase. Okay. All right. Suppose that in 1985 there were 285 cell phone subscribers in a small town. The number of subscribers increased by 75% each year. How many cell phone subscribers were in the small town in 1994? So let's work on that part first. So what we're doing is the same as right up here. Y equals A times BX. Okay. So Y equals A times BX, B to the power of X, where A is the starting number. So in this case, it's 285. B is found by taking 1 plus the percentage, 0.75. So we're going to get 1.75 to the power of X. Okay. So that's the formula, but now it says how many cell phone subscribers were in the small town in 1994. Okay, well, if it's 1994, that's 9 years. So that means this number is now a 9. So we have Y is equal to 285 times 1.75 to the power of 9. Okay, so we put that through the little evil demon box, and what we end up with is 43,872 people in the small town now have a cell phone. Okay. So we label it people or subscribers. Okay. So it started with 285. That's the beginning, that's A. We added 1 plus the percentage, that became B. And then the exponent was filled in by how many years we were dealing with from 1985 to 1994. Okay? Now, write an expression to represent the equivalent monthly cell phone subscription increase. So this is where we're going to go back, just like we did here, 1.07. We're going to do 1.75 to the 12x over 12. So we separate that 1.75 to the 1/12 to the 12x. Okay. Now we need to figure out what 1.75 to the 1/12. Okay, when I did this, I got 1.05, and then I replaced the 12 to the 12x with the letter m. So this is the answer to the second half of the question. 1.75 to the 12x over 12. I pull out 1.75 to the 1/12, leaving me with 12x. This becomes 1.05, and I replace 12 times the number of years with m, and that becomes the answer. So that is the section on growth. Okay. Basically, you're trying to remember the formula. A is the starting point, B is the growth plus 100%, and X is the amount of time that we're dealing with. If before you move on and watch the second video, maybe you want to flip to a spot in your book, see if you can find a growth formula and work on that question and see if it helps.